get this on record. So good morning, everyone. We are still continuing with the software designs. There is no way you can claim to be a software engineer. You cannot claim to be a systems analyst if you cannot communicate your work processes with others. So now, one of the ways through which we communicate with the other team members, other stakeholders, is by coming up with the models so that we can inform the rest of members on team on how the system should function, what we expect from the system, and therefore that is why we see that we have what we call the software designs, which software designs can be made in different ways. And therefore, the unified modeling Unified modeling languages. So, and when I talk about the unified modeling languages, it is just a way to use diagrams to visualize a system or even a database. Yes, any way that you can put the system into visual architectures, into visual artifacts, into visual layouts, then you are carrying out unified modeling language, and you want to inform other members on the team on what they should expect from the system. So systems analysts and software engineers use unified modeling languages or diagrams to understand the design, to understand the code architecture, as well as the proposed implementation of the complex software systems. Yeah, and on our practical bit, we are going to use various tools depending on what you prefer, because when it comes to unified modeling languages, we have thousands of tools that you can use to bring out the visual, appearance, visual representation of the system or the database, how you want the system to do what? To be. So now, when we talk about, this is the one I've already talked about it, and we have, or there are quite a number of types of unified modeling language diagrams. These include use case diagrams, we can have class diagrams, we can have activity diagrams, sequence diagrams, as well as the rest. But now our today's focus should be on the use case diagrams, Yes, like I said, we have already done the graphical user interface, but this should come first before the graphical user interface. Why did I bring the graphical user interface first? Is because it takes some time. So now we shall design our UIs using or benchmarking from Behance, being that it's one of the great source when it comes to benchmarking of world-class UI designs. That is why I always use it. So that is why, whatever kind of design you may be looking for, once you search it under Behance, you will be in position to find sample or already existing designs in the same line of interest. So, and then you can use Adobe XD, you can use Figma, or even other design tools for your UI UX designs, but following what you have already visualized in for example, use cases you get. So now we are going to focus much on the use cases. Now, why do you think, or why would a professional systems analyst or software engineer embark on using UMLs or using use case diagrams? Is basically to understand the design, like you're trying to inform other members on the team how the design should be, It also helps in understanding the code architecture, how the code should be structured, as well as the proposed implementation of the system you get. So basically, these UML diagrams helps to inform the team members on how the system should be, you get. So, but like I have always been requesting, the moment I talk about something that is not clear, please feel free to raise up, and then we are able to do what? To iron it out. The way how Kato was very clear that we cannot hear you, otherwise I would proceed with the entire session for full, maybe, hour minus getting to know what you guys are thinking about it. So it is always good that in case of anything, please do it in a real time so that we move at the same pace. So in designing use cases, we are going to use different tools on the practical bit. Yeah, depending on how convenient they will be in terms of subscription and so on. So maybe we shall have to use some open source tools like iDraw, like Lucid Chat, and so on, because there are quite a number of tools, platforms where such diagrams can be designed from. So uh, the use case diagrams, uh, these use case diagrams are just uh, graphical depiction of a user's possible interaction with a system. I think I have it. Yes. So these are sequence of actions that the user takes on the system to get a particular target. So basically, what you have to know about the use cases, like last time when I met you, I told you there are things that when someone mentions, for example, when someone mentions about maybe Centenary Bank, there is something that comes to your mind. That is why even Centenary Bank had even a slogan. I don't know if they still use it, but they had a slogan that meant it is the bank for the ordinary person you get. So that is why you see that Centenary Bank might be the leading, financial institution in terms of numbers you get. Yeah. So now there are things that when someone talks about Uganda, let's assume someone is not a Ugandan, someone is not in Uganda, but you mention to them the word Uganda. There has to be something that always comes to their mind the same way how I told you when we were discussing about system development life cycle methodologies, and then we went to agile methodology, and then we decided to focus much on some of agile frameworks. And I told you that every time you hear someone talking about agile, just to know that they are talking or referring to an incremental and an iterative approach when it comes to coming up with software systems. Now, the same way, when we are designing software systems and someone mentions the word use case, we are basically referring to a dialogue between an actor and the system. An actor and the system. How does an individual react? How does an individual work with the system? So those are use cases. Any graphical representation, any diagram that offers as such is what we refer to as the use case. So it is a dialogue between an actor and the system. So an actor, when it comes to the database as well as the system designs, it is basically referring to an individual. An actor can be an organization, an actor can be even just an external device that interacts with your system or that is connected to your system. You get? So a use case diagram, like I told you, is a graphical depiction of a user's possible interactions with the system. You get? Yes. So a use case diagram shows various use cases and different types of users that the system has and will often be accompanied by other types of what? Diagrams. So why the use case diagram? The main objective of working with research is to represent the goals of a system user interactions. You get? Also to define and organize functional requirements in a system, because obviously when we are coming up with these use cases, you realize that when the use cases are extracted from what a system does. And what a system does, those are the functional what? Requirements. So they also specify the context and the requirements of the system, modeling the basic flow of events in use case. So these use case diagrams are intended to support requirements engineering, like I have already shown you here, that they actually specify the context and the requirements of the what? Of the system. Yeah. It is an effective means of communicating with the users and other stakeholders about the system and what it is intended to do. I've already talked about this. Yes, for them, they will obviously let you know what the system is supposed to do through the use cases. Yeah, because use cases have what we call like components that we are going to look about. And among the components is where we have the use cases. The use cases helps in describing what a system does. And one of the strong pillars of use case diagrams is that they capture different actors' views of the system. You get? Whereby you get to understand what people expect from the what? From the system. But when it comes to the negative side, you realize that there is no particularly strong in capturing non-function aspects, because use case diagrams are high-level diagrams whereby they don't go into details, but they will just present an overview or a summary, of the entire system. That is why now issues like non-functional requirements are not captured in this case. There is what we call functional requirements and non-functional requirements whenever we are trying to do what? Gather requirements for a system. When we talk about functional requirements, we refer to features a system must offer. You get, for example, if we have maybe a student registration system, can students register? Can they log in? Can they maybe, submit whatever details they need to submit? Those are functional requirements. Then when we talk about the non-functional requirements, let me give you an example. When you go to the bank ATM, the main objective as to why you have gone there, it can be to withdraw or even to do what? To deposit. That is, those are functional requirements. But then there are machines that you will go to and the process takes you like maybe 5 minutes. You get, whereby now there is an element or a function called the non-functional aspect of it is the time bit. You get, yeah. So time is a non-functional requirement that has to also be looked into. Then we have what we call components of the what? Of the use case diagrams. You get? Number one is what we call the use case. we have the actors, we have the relationships and others that the way we are going to look at them. You get, yeah, we are going to look at them. What you have to know is every time we meet either physically or remotely, making your own notes is very, very important because most of the content, most of the things I talk about, they are basically out of experience. The notes for the slides I'm scrolling through, they are just a guide, you get. But what matters a lot is what I tell you, you get. Because these are things that I've worked with, these are things that I'm working with. I mean, so I base on an informed point of view to tell you whatever I'm telling you, you get. So now, when we talk about the components of the use case diagrams, we can talk about one is the systems, and a system can be things like we can talk about uh, in a system we can talk about whatever you are doing, whatever you are developing, you get. Yeah, this can be a website, it can be software component, it can be business process, it can be an application, and anything that you're doing, you are developing, that is a system. And one of the components of the use case diagram is what? Is a system, you get. Normally represented in a rectangle kind of layout, you get. So now another component we can talk about can be use case themselves, and these are always represented in oval format, you get. The way how you see this one, it is an oval layout, which is a use case. And now, then we also have what we call actors. Now, these actors always represented by this kind of human mimic, human, uh, human what? You may call it whatever name you prefer giving it. These are actors. And when we talk about actors, actors can be someone or something that uses the application to achieve a goal, because now it is now this actor that will use the proposed system to achieve something. So now that is why we refer to actors as someone or something that uses the application to achieve a goal. This can be a person, it can be an organization, it can even be another what? System that interacts with your system, or that you intend to interact with your system, for example, through APIs. Then it can also be an external device that you intended to do what? To connect you to your proposed system. So those are what? Those are actors. Then lastly, we have what we call the relationships, you get. Yeah. Now, sometimes you could be explaining your system to individuals, to team members, to stakeholders, and you want them to perceive it in a way you also do what? You also perceive it, but they cannot get it the way you do what? You prefer. That is why now, the moment you put your idea on paper, you put your idea into a design, by the use of use cases, it brings or it simplifies, the explanation, it simplifies, the level at which you would prefer every individual on the team to perceive your idea, because it shows the system, the way how you would basically prefer it to be. So, like I've already told you that use cases are high level what? Diagrams that actually just look at an overview, a summary of what a system should do and how people should interact with it. Yeah, because when we talk about maybe high level diagrams, we are referring to like an overview, an entire system. Yeah, where you have to identify the main components that would be developed for the product you get. Yeah, basically minus looking into the integrities of these what components. Yeah. Very good. Like you, I've already told you that a system is one of the components of a use case, and yeah, I can. I think I can do something. Oh, last time I must have asked some members to do what? Some members to Google about use cases. Yeah, then we can have use cases inside here. Then we can have other what? Other actors, where we shall have to look at the primary actors as well as the what? The secondary actors. But we are going to reach there. So, but I was showing you how a system uh, should be. For example, this is what we are trying to maybe come up with to design. Yeah, whereby now here you will give a title or the name of the system that you're trying to do what to propose. For example, guild guild voting system or guild voting application, because I told you that a system is this rectangular kind of design. But whenever we talk about a system in design, we can refer to whatever you are trying to do to develop. This can be a website, it can be software component, it can be business process, it can be an application or anything else you get. Yeah. And now that is why you see here that the scope of a system can be represented by a system. This one is what I'm referring to. Yeah, it is the one that talks about or brings out the scope of the what. When we talk about the scope of the system, we are referring to what a system should offer, like the boundaries you get. Yeah, the use cases of the system are placed inside the system shape because these use cases are the ones I'm talking about, which are placed inside the what? The system boundaries. It is because this is what a system should do. And the reason why actors for them are placed like they are outside the system is because they are external. They just interact with the system. You get? Yeah, while actors who interact with the system are put outside the work. Very good. Then we have what we call, excuse me, we have what we call uh, relationships. Yeah, we have what we call relationships, which relationships have types. We have what we call generalization, we have include, we have uh, there are quite many kind of relationships that we can have between the different actors as well as the system itself. You get? So when we talk about an include relationship specifies how the behavior for the inclusions use case is inserted into the behavior that is defined for the base use case. Let us go here, and these ones you go through. These are just all examples of relationships. We have relationships which are called include. We have those that are called extended as well as generalization. For include, we told you that for them, uh, they specify how the behavior for the inclusion use case is inserted into the behavior defined for the base use case. But now, the one which is let me see if I included what. Uh, I didn't include. Okay, we can use this, whereby when we talk about relationship, an extended relationship is an extended relationship that shows how velocity velocity. Oh, what happened is that
Your screen is off.
not sure what had happened, but good, we are back. Okay. We have an extended relationships. Relationships are always represented by what? By these arrows you see, maybe from now an actor to the system, or from an actor to use cases. So this one specifies how the behavior of an extension use case can be inserted into the behavior defined for the base use case. And so now, uh, let us look at one of the components, what makes up a use case diagram. One of them being the actor. I have already told you that an actor can be someone or something that must interact with a system under development, or must interact with a system that you're working on. And I told you that an actor can be an individual, it can be an organization, can be an external system that wants to work with the system you're working on. It can even be just an external device that you want to connect it to your what? To your system. So when we are designing systems, we have to put these to outline them so that someone who is going to be part of the development will get to know which organizations we must connect to our system, which individuals are going to work with our system, which external organizations whose APIs we need to integrate within our system, which other external devices do we or shall we need to connect to our system. So that is why I'm saying that actors can be human or even automated what? Systems. So because being that actors are not part of the system, that is why when we are designing use cases, we put them outside the system, like I showed you here. Yes, you see, these are the actors. They are placed outside, but then we just show the relationship between them and the system. We have the primary actors and the secondary what? Actors, but we shall get there. So UML notations for actor is stickman, whereby actors carry out use cases and a single actor may perform more than one use case. So actors are determined by observing the direct use cases of what? Of the system. We have what we call the primary actors as well as the secondary actors. Now, like I said, you listen carefully. Listen carefully. When I talk about primary actor, oh, when, like I've already told you that actors are external objects. That is why they are always placed outside the what? The system. You get. But actors need to be thought of as types, or you can call them even what? Like categories. So now we have the primary actors and the secondary actors. Now the primary actors initiate the use of the system, like they interact direct with the system. I can give you an example. Let's assume we need to work on a simple application, like maybe a banking application, right? Now, a banking application, you know very well, what like we have actors like customers. We also have, remember now ours is an app. We are now, our system is the app. You get, yeah, this one. This one is the what? The one I'm referring to. This can be like our banking what? Our banking app. You get. Now, if this is our banking app, we expect customers to interact with it, but we also expect to link our application to the bank, meaning that now the customers here interact with the application directly. You get. That is why I'm saying that a primary actor acts on the system because they initiate an interaction with the system. They use the system to fulfill their what? Their goal. Whereby even some things we don't have control over. I can give you an example whereby it is, if we are to work on maybe a banking application, we can have customers that initiate the use of this application, whereby they will pull out their phones, they can open the application, that is after downloading it, and then they can do something with it. You get. Yeah, because they download and use the application. So they have that they initiate the interaction with the system. But when we talk about the secondary actor, it is acted on by the system. It is now the system that is going to do what? Now to act on to the secondary actor. It is now our application that the moment an individual downloads our application and uses it, for example, they log in. After logging in, then maybe they need to check their current balance, our account balance. Then it is now our system that is going to link the bank through the API and check if this particular customer has sufficient what? Funds. So now you realize that we have the primary actor that initiates the use of the system. But then when we talk about the bank, which is the secondary actor, for them it is more of reactional, whereby the bank is only going to act once the customer does something. When you do something on your application is when now the bank will react. So that is why I'm saying that a secondary actor is acted on by the system, helps the system to fulfill its goal, because now the system could be there that it wants to display people's balance. It wants to display or like make payments of certain bills for the customers. So yet the application doesn't have the money, but the money is from the From the bank. So something the system uses to get its job done is what we call the secondary actor. I don't know if you really pick something from what I'm trying to to explain, but I wish. So it is after when the customer goes to the application to check balance is when now the bank will engage our application. So just an emphasis on trying to understand what the secondary actors are. It is when, for example, if we are to consider a banking application as one of the system we are trying to do to come up with. So we shall basically consider customer as being the primary actor, and then the bank being the secondary actor. So primary actors should always be, when we are going to go on to how to do how to design this. so that you get to understand where to place what, because all these components have special positions where they're supposed to be. And before we actually even conclude this day, I am expecting that each and every member who belongs to this class will bring, or will, those who have already started working on an assignment that required you to come up with a problem domain or a topic or an information system where you're supposed to design UI UX designs or pages. It is better that you maintain, and it is that very problem domain or information system topic or title that you're going to use to come up or to generate use cases whereby you properly define your primary actors, your secondary actors, your use cases, the system, and the relationships you get. But we are going to go much into this. Generalization is one of the relationships, is one of the relationships. But before we go to relationships, we have what is called, yes, these are relationships. These are relationships, and we have various types of what relationships, because I told you that we are looking through the components, what makes up the use case diagrams. And we have looked at the use cases themselves, the actors, we have looked at the system, and now number 4 is the what? Is the relationships. You get, yeah, the relationships. We have what we call association relationships, we have generalization relationships, we have the include, we have the extend, you get. All these are different what? Different relationship types. Now, generalization is a relationship between a general use case and a more specific use case that inherits and extends feature to it. We are going to see this in the details so that you can try to understand. We have and before we go to that example, I think I need also to tell you that use cases that are specialized versions of other use cases, because like I've told you that these relationships, or I showed you that relationships are these kind of lines that move either from an actor to a use case, or from one use case to another, depending. So now it is shown as a solid line with a hollow arrow that is pointing the way how you see this solid one, you get, yeah. And then now if we have an example of maybe the actual order registry clerk, which can instantiate the general use case place order. We have now the place order where we have the different use cases and actors, what the person is expecting from the system, where we have order registry clerk, we have another actor as customer, another actor as the online customer. So meaning that this clerk will place orders, and then the customer, the ordinary customer, will obviously make their orders through the phone order, and then the internet customer will make theirs through the internet. At the end of the day, the main target of goal is to place what? Place orders. So place order can also be specialized by the use case phone order or internet order. How to create, we are going now to the practical bit. How to create the how bit is the practical bit. That is why I told you, yeah, we always approach whatever issue on ground by the use of 5WH. Once you get to understand what use case diagrams are, then why do we need them? We have already looked at such. When do we need them? When the system seems to be complex, but we need to inform, or we need to ensure that everyone on the team understands and interprets it in the same way. That is the when. Then we also need to see or look at the how. Are these what? How are these designed? That is the practical bit of it. Yeah. List main system functions. The functions of the system are the use cases, and these ones are always placed inside the rectangle that represents the system itself. Yeah, in an oval what? An oval form. Yeah. So if this is our system, then we can have use cases inside the system. These use cases you see inside the system. Then we can have our actors, which are external in nature. We have the primary external on the left, and then external, secondary external on the what? On the right. Yeah, and then we can relate the relationships. If this relationship is association relationship, then obviously we do it with a solid what? With a solid line. So think of business events demanding systems response, then users' goals needs to be accomplished via the system where they can create, they can read, they can update or delete. In database, it is called CRUD. You know? Yeah, CRUD when it comes to user permissions and roles. You can all be users of the system, but with different what? Permissions. That is why when you go to the bank, what a teller sees is not what a bank manager or the supervisor sees. They are permissions that can only and only be performed by the branch supervisor or the bank manager, and it cannot be performed by the teller because their permissions on that particular data can be just to read, but not either to create or to update, neither to do what? To delete, when it is just read only. So naming use cases, users' needs usually can be translated in data. So all these ones you will read through and do what? Understand. Now, let us go to this example. Begin with a use case. A user placing an order with a sales company might follow like this. I want you to listen while watching critically. Let's assume you have been tasked to come up with a system design for a certain company that deals in selling commodities, to customers. So now they want you to automate their system. What happens is you're going to have where we have a user placing an order with a sales company. You get? So now you can call it any of your choice, but the main target or the main goal is, can a user be in a position to place an order from the sales company? Now look here. We look at the different use cases, Yeah, we have to start with the use cases. Like I told you that use cases is what a system must do, what a system does, because for them they describe, that is why they are placed inside the what? Inside the system. These are use what? Use cases. So, um, uh, we shall have features like the user must be in position to browse. We shall have to, sorry for some bit of breaks. Yeah, but I'm saying if we are to design such a system, we need to consider what we call the futures. Now it is these futures that we're going to convert into use cases, whereby one of them is we have to ensure that the user can browse the catalog and select the items they want to do what? To basically make orders on. Then they can call the sales representative. Then the supply shipping information has to be provided. Supply payment information has also to be what? Provided. Then they can receive confirmation number from the sales what? Person. Then translate use case sequence into diagram here. Here. Yeah. We have the user here who is the customer, and we have the different cases, the different use cases of browsing catalog and selecting what items. Then after that, they can call. These ones can be inside the use case, only that the words were long that they could not fit in, but they are already what? Inside. Now, call sales person, give shipping information, give payment information, then get confirmation number. You get. So now, all of these are relationships. That is why you see that it is the customer who has to browse the catalog, selects what? Selects the items. They will also, what else they have to do on the system is to call the salesperson, is also to give shipping information, give payment information, as well as confirmation to get. So the salesperson could also be included in this use case diagram because the salesperson is also interacting with the ordering what? System. Now, we have actors here. This is the system. You see the system as a whole. This rectangle you see is the system we are trying to do. What we are trying to uh, come up with different actors, the people who are going to interact with the system, where we have the customer, where we have the cashier, as well as the admin. But remember, these people have different roles and privileges on this what? On this system. Now, look here. When we have a customer has the relationship the customer has with the system is just a second, please. A second, a second. Mm, okay. Um, mm, okay. Sorry for that. I was still telling you that, let me hope you're still seeing my screen of the use case diagram example 3. Now we have, are you still there? Can you hear me?
Yes, yes.
Okay, thank you for the feedback. Yeah, we have the customer, we have the cashier, we have the admin. These are all actors on this system. We are trying to do what? To design for either the supermarket or the sales, company. But we are trying to come up with a point of sale system for them, whereby a customer can a customer has different relationships with the different, like now these cases, use cases you see inside in an oval format, they are like what a person, what an individual, what an organization, or basically what an actor should do on a system. You get, for example, the way you see, like a customer should be in position to return purchased items, and this person should be in position to pick item, should be in position to show items to cashier, and so on. They are even also able to receive a bill. Then a cashier should be in position to sign up. A cashier should be in position to log in. After sign up, you have to log in. And now we have a relationship called, this is the relationship from a cashier to login, which is association relationship. But we have another relationship when it comes to the login future or the login case, use case, which is include relationship with those dotted lines, meaning that the moment a cashier attempts to log in, they have to verify, like log in by entering the username and password. You get, yeah, of which they can also now proceed to verifying username and what and password before they can proceed to perform something else. Yeah, for example, now receiving items from customers, bidding those items, as well as creating a bill and also receiving cash, So basically, these are relationships, what the different actors can do when it comes to what? When it comes to the point of sale system. That is why you see here, we just listed them. We get these use cases from the requirements, what a customer is expected to do what to get from the system. So this is we have another one for a vending machine. We also have another simple one, like, okay, this is for a vending machine whereby after client interview with a after client interview, the following system scenarios were what identified. A customer buys a product. The supplier restocks the machine. The supplier collects money from the machine. You get. Now, on the basis of these scenarios, the following three actors can be identified. We have the customer, who is an actor. We have the supplier, who is another actor, as well as the collector. You get? Yeah, though still the collector is another supplier. You get? It's a supplier, but with the privilege or with the permissions to do what? To collect the money from the machine, because not every supplier might have those what permissions to do so. But now the one with the such permissions is the one we're referring to as the what? The collector in this case. So we have the entire system, or our system, as the vending machine. As you can see, this is the system we are trying to do what? To design, a system in a rectangular format. But then we have actors, where we have the customer. Then we have another actor called the what? The supplier. Now, the vending machine has a relationship with the customer, which is the customer is intending to buy the product. You get? Yeah, with this are buying the product, the relationship between the customer and this use case, or a future. Like I told you that these use cases are generated from what a system should offer. That is why you see now these ones, the customer buys what? A product. Yes, and that is why we have this use case as buy what? A product. Now, we have what we expect from the supplier is to restock the what? The machine. Yeah, the supplier will restock the machine. At the same time, the supplier can collect the money from the what? From the machine, collect the money. All those from this what? This actor. You get? Introducing annotations or the notes as well as constraints. Yeah, we have customer who can be, an employee. Those are just notes that are added onto this. But together, I want us to go to the practical bit together. But maybe before we can go there, in case you have any question, please feel free to raise it so that maybe we can talk about it before we can now go to the practical bit. Any question, please? Hello, are you there? Pato, are you there? Semwanga, Kathy?
Yes, sir. I'm here.
Yes, sir.
Okay, no problem. Maybe what we can do is let us first, I need to stop this recording.